and welcome back to the channel, everyone. Today we're going to discuss equations with fractions, and I have two different examples here. We have some integers and fractions, and we want to be able to delineate between the two and how to really solve here. Okay, so I bring these two up because we know we want to use reverse order of operations, but sometimes our choices are limited here. Right? So in the first example versus the second one, what is different is that I have an entire quantity, 5x minus 3 all over 9, versus the second example I have over here, I have just 2/3 x plus 17 on one side. Okay, so here there's a little bit of a difference between what step I use first and why. In reality here, I technically do have 5x over 9 minus 3 9ths. I could just place them both over 9. And then if I wanted to, I could add the 3 9ths to both sides or the 1/3 of both sides. But actually what I'm going to do first here is, as you see, I grouped that in a parenthesis up top. That actually is going to be a piece of how I focus on my reverse order of operations. So I can't actually simplify here, and there's no addition or subtraction. But what I do have is I have division here. So what I'm going to do actually is I'm actually going to multiply both sides by the reciprocal here of 9, which is, 1/9, because that's technically a 1 times that quantity, 5x minus 3. And I'm going to cross reduce. Okay? And then on the other side, I do equally to both sides, okay, because I'm following that multiplication property of equality. The nice thing here is I can cross reduce my 9s because I know how to cross reduce. And then the only thing that's left that's not 1 is this 5x minus 3, and that quantity will just drop in to my next line. And then multiply 11 times 9, ends up being 99. And then I'm just going to follow, again, reverse order of operations. Now my order of operations reset. I'm going to add 3 to both sides using that addition property of equality. 5x is equal to 102. And I divide both sides by 5 using division property of equality. X is equal to, you could leave it as 102 over 5. Or if you would like to convert that, you certainly could make it 20 and 2/5. Both would be acceptable here because it is already a reduced fraction. Okay? Now the second one, I said there's a little bit of a different step. I could actually multiply both sides by the reciprocal here of 2/3, which is 3/2. But the problem with that, the piece why I wouldn't go that direction is because technically I would have to distribute that to the 17. And the 17 is not divisible by 2. Not to say that we couldn't do it, but it's probably not the path of least resistance here. Okay? Now, the difference here, though, is this 17 is not in the numerator. So actually, I can use my reverse order of operations and get rid of it to clear it to the other side. So what I am going to do first is I am going to subtract the 17 from both sides. I'm left with 2/3 x is equal to negative 21. And now I'm going to multiply both sides by the reciprocal of 2/3, because we know the reciprocal property, anything times its reciprocal is going to get 1. I'm going to do that on the other side. I am going to place the 21 over 1, just in case I can cross reduce. I have a bunch of 1s here, so I'm left with 1 single x. And then unfortunately I can't cross reduce, so then I just multiply straight across. So I have negative 63 over 2, which you could leave that is fully in reduced form, or if you want to make that a mixed number, ends up becoming negative 31 and 1/2.